For every trained and skilled mass spectrometrist there is out there in the world, there are 10,000 biochemists and clinical chemists and medicinal people who are making molecules, working with molecules in everything they do all the time, but they need to know what those molecules are.
Mass spectrometry is a very, very accurate weighing of something. So if we know exactly how much it weighs, we can tell what it is. And then what we can also do is cause the molecule to explode into lots of different pieces. And then it's a bit like a jigsaw puzzle in that we're putting all of those jigsaw pieces of that exploded molecule back together. And once we can do that, we can tell you exactly how whatever you had was made and put together.
It's the only technique that can actually handle incredibly complex systems. And so when we try to move to biological systems or environmental systems, real world analysis, mass spec's always at the forefront of that.
So I'm working on antibodies. So biopharmaceutical companies are producing antibodies to act as drug and help us cure certain disease or treat them. My job is to look deep down on the antibodies, see if there is modification, if they are toxic or not.
The Fourier transform ion cyclotron resonance that is in the instrument room, it's a very high resolution mass spectrometry technique. My project is about separating isomers. So isomers are things that look the same, have the same mass. So it's really important that we do differentiate them. So I'm looking at this differentiation in a lot of biological systems, so a lot of proteins and peptides.
We have a set of drugs that are made by material science teams over on the main department, and we're looking at how they are made and making sure they're making what they think they're making. They're very complex polymer species, so we need to make sure that they are definitely they're not being modified in any way that's unexpected during the synthesis process. And then we also look at how they can interact with one another.
Mostly I focus on developing new mass spectrometers to analyse more complex systems, but also to do anti-cancer research with those things we develop. So we're focusing on how new drugs might be able to attack cancer in different ways, why they attack them in different ways, and how we can then use that information to go back and use intelligent drug design to change the design of the drugs in the first place, and then we test and see how we can attack cancer more effectively.
You drive your project, so you need to find out what you're interested in, communicate with your supervisors, with your colleagues, ask lots of questions, do a lot of reading. It all comes from you.
I came back to Warwick because of the academics we have here, the interesting research we have, and the facilities that we actually provide.
The growth in this field has been phenomenal, about 20% per year for my entire career. And of course, we're always increasing demand because we're developing new instruments and new capabilities all the time. The future of mass spectrometry is extremely bright.